All right, guys, we're starting now. So I'm here to talk about, both of us, we're here to talk about raster analysis and image processing within ArcGIS Enterprise. I'm Vinay Vishwambaran. I work on the imagery team. And this is Jay Zhang. He works on the imagery team as well. So how many of you have worked with the mosaic data sets, image services, aware of raster functions? Okay, quite a few of you. So this is supposed to be a focused application, a focused presentation on raster analytics. But what we're trying to do is blend in image processing, image analysis within ArcGIS, and then gradually we get into implementation patterns of raster analytics. So first, I'll start with patterns of use, which is an introduction to image processing, client server-side processing, desktop versus enterprise processing, a couple demonstrations. Jay will go into the crux of the presentation. He'll take the beef, which is raster analytics, configuration, systems deployment, and much more. So a lot of you have probably seen this slide already, similar slides. ArcGIS is a platform. Now, ArcGIS is also a comprehensive imagery platform. It provides a system of record which essentially manages and processes large volumes of imagery to create rich information products. And this is basically the primary information model here is the mosaic data set. The next ArcGIS provides a system of engagement, a system of insight. This is used to extract meaningful information from imagery by performing analytics on these massive volumes of imagery. ArcGIS provides a system of engagement, essentially creating the applications that enable rich applications that enables imagery to be accessible in a variety of engaging and immersive applications. Now, this could be web, it could be mobile devices, it could be desktop. Now, like any other system, content is a critical component as well. So there's a ton of content that we provide that is provided by either business partners or by a user community or Esri curated content. A lot of you, I'm sure, have worked with the Living Atlas. You've seen a lot of the data that's available on the Living Atlas. ArcGIS Enterprise is a key component of this system. The Enterprise, it comes, as you can see over there, it comes with a variety of roles, multiple roles. What we are here to talk about primarily is the ArcGIS Image Server role. So that is going to be focusing on the system of insight. So here's a quick overview of different image processing techniques in ArcGIS. So we have our geoprocessing tools. A lot of you have been using forever. This is traditional image processing, process a collection of images, write out a collection of processed images. This is, again, like I said, traditional image processing. Out of the box, we've provided about more than 100 different tools to process and to manage your imagery. We have the ability to process and create tiled maps. So step one is georeference your imagery, then you color balance your imagery, seamline generate your imagery, and eventually create a cached image or a cached tile, a processed set of tiles. And it's been a decade, I think sometime in 2007 when we introduced Image Server. That was when the birth of Image Server really took place. And here is where we had this paradigm shift of image processing where we enable users to create on-the-fly dynamic information products. So it's analogous to geoprocessing, only difference being you're processing your imagery on the fly. Now these functions, or these raster functions, they can be applied to either raster data sets, you can apply them to mosaic data sets, and you can apply them to image services. There are three patterns. Now, when I'm talking about raster functions, there are three patterns to process your imagery within ArcGIS. Now, this directly depends on the type of user you are. As you can see right there, you have client-side, server-side, enterprise. So an individual who's working on a desktop, who works with imagery locally, he processes the imagery locally, right? Everything resides locally. He uses his client application, the data resides locally, brings it into ArcGIS Pro, runs a process. Simple example, NDVI. I pick my Landsat image, do an NDVI representation, and I get to see a visual representation of my information product. This processing is done on the client. Pixels, as you can see, are processed locally. Processing is done on the fly, and is primarily used for visualization purposes. Next is server-side processing. The user in this case would be an enterprise who's running their image processing on a server. Imagery, again, is processed on the fly, but in this case, it's not done on the local client. It's not done on my desktop. It's done on the server. Imagery is served, accessed via image services in this case, and the author of the service typically predefines a set of processing templates which a user can directly use. So if you work with the Landsat services or the elevation services, we provide a few processing templates which you can use directly. In this case, the processing is occurring on the server. Simultaneously, I can set my own processing that can be done dynamically on the server. Again, this is primarily visual products, and again, this is on-the-fly processing. Next is enterprise. And just one second. When do you use the enterprise? Typically, it's an individual who's trying to solve a much larger problem that you typically cannot run on a desktop. For example, there is one of the demonstrations that I'm going to be showing you, a solar power plant suitability model. It took me 5.5 hours to actually generate it on my machine. Using the power of enterprise, the whole thing ran within 16 minutes? 30 minutes, right? So the job is defined, it's sent to the enterprise, the raster function template is sent to the enterprise. The enterprise then distributes the processing to the available cluster of machines. It writes out a persisted layer. So that's the big difference as well, in terms of processing. The previous two sets I mentioned, the client side and the server side, when you're leveraging the enterprise, you're creating persisted products, right? Okay, so we're primarily going to be focusing, like I said, on enterprise, the 3 different patterns which I talked about before. Our focus today is going to be on enterprise. And before going for an in-depth tutorial of distributed raster analytics, the architecture and components, here's a rundown on raster analytics in general. Firstly, you have to enable, it has to be enabled on the enterprise image server. It works with your existing GIS data and your existing imagery. It just works. It's optimized. It optimizes your output imagery in the distributed raster framework such that you have, so we have the specific data format wherein we enable multiple writes and multiple reads. So it's highly optimized. The output is also highly optimized. And Jay will be talking a little more about this. Distributed raster analysis relies on ArcGIS server, obviously, and it scales up and down based on user requirements. It's primarily developed for processing of large data sets, 1 billion pixels, for instance, or data sets that spanning large geographies. The machinery that we use here is a combination of all of the technologies that I mentioned previously. Firstly, on-the-fly raster functions. So essentially, I'm sending a raster function template to my server. So there you see raster functions coming into play. Next is the existing geoprocessing framework. Next is the power of the enterprise, and we leverage all of the associated information models. So all of this put together, we come up with raster analytics. This slide, a little messy, feel free to take a picture of it, but this is all the processes currently that we're supporting out of the box. And if you notice, on the extreme right, there is the Python function wherein you can establish your own custom algorithms. So if we don't provide a specific raster function or image processing algorithm, you can implement your own custom algorithm within the Python framework and leverage our on-the-fly processing capabilities. I'll quickly dive into some demos, and then I can hand it over to Jay. Okay, so you guys are looking at a worldview scene. This is a 30 gigabyte image of worldview. This is over the area of Sonoma. Now this is not a pre-processed data set. This imagery is being processed on the fly. So I'm rectifying this imagery, I'm pan sharpening this imagery, enhancing the imagery, and creating a natural color representation of the data set. All of this is on the fly. How do we make this possible? ArcGIS provides you with unique image processing capabilities, again, like I said, by way of raster functions. Raster functions are essentially just image processing algorithms that can be applied to imagery either on the fly, or they can be applied to create persisted raster products, raster information products, right? A quick rundown on raster functions. So out of the box, ArcGIS provides you with a slew of raster functions. You remember that slide that I just showed you? These are all of those functions that are available. You can quickly pick one of those functions. Pick a data set. You can specify your parameters. In this case, what is my visible band ID and my infrared. And I can pick a color map. So sub-second response, I've just created an NDVI representation of the same data. So this processing is a local data set, and the processing is occurring on the fly. It's occurring on the client. Now, I have another data set. Let's navigate over to another area. This is the more recent fires that had occurred in Sonoma. And this is what the data set looked like before the fires, and this is what it looked like after the fires. Now these chains or these raster functions, they can be chained together to create custom raster functions, right? So here I've created a custom function chain which performs a burn scar analysis. It takes my input set of rasters, it does a bunch of processes, and the output is eventually a delineation of the burn scars. So I can apply this function chain. Pre-image is this, my post image is picked. So in a couple clicks, you can see how I've actually chained all of my functions together. I can save out this function chain, I can share it through ArcGIS Online, and I can apply it to my local machine, to my local data sets. So that was local data sets on the fly processing on my client. Now, from local data sets, you can do the same thing on image services as well. So this is the world elevation services which we provide to all of our users on ArcGIS Online. You can pick the data set, and I have a custom, let me just show you what the function chain looks like. So this function chain is also a custom function chain. It performs a terrain ruggedness index. Close this. My input, pick my layer. So here's my terrain ruggedness index. It's generated on the fly. So here the difference between the previous demonstration that I showed you is the data doesn't reside locally. I'm pulling it from an image service. But you have to keep in mind the processing, again, is occurring on the client. So the resources that I'm using is everything that is on my client. I'm not using the power of my server as yet. So now moving from client-side processing to the server. I can show you how we're leveraging the server to do all of the processing. The elevation services, like I said earlier, we provide you with a set of predefined processing templates. What's a processing template? It's essentially a raster function chain, right? This processing template, in this case, we provide you with a variety of information products. So I can switch to an aspect map, multi-directional hill shade. There's much more in this list over here. I can switch back to grayscale hill shade, right? So you see the power over here. My processing in this case is done on the server. But again, all of these processing templates is defined by the author of the server. What if I have my own processing that I want to run leveraging the server, and I want to do dynamic processing? So we've added a capability again in ArcGIS Pro, wherein The same process, the terrain ruggedness index, which you saw me running on the client, I can add a custom process, pick custom, terrain ruggedness index. The result in this case is the terrain ruggedness index, but the difference now is the processing is occurring on the server. I've sent my processing instructions to the server. The server processes a terrain ruggedness index and sends me or transmits me the imagery or the terrain ruggedness processed dynamically on the fly to my client. So all my client doing at this point is rendering the imagery. So that was server-side processing. We talked about client-side processing. Then we talked about server-side processing. But many a time, what a user really wants to do is create a persisted product. Everything that I showed you so far was on the fly. The processing was on the fly, right? And that's where Raster Analytics comes into play. So here's another use case wherein I have multiple inputs. Okay, this should come up anytime now. So this is the the elevation data set over the United States. I have the land cover data set, mean rainfall, and lastly, mean temperature data set, right? I want to put all these data sets together, and I want to create a solar power plant suitability map. To do that, I have my own custom function chain again. Let's see what it looks like. It takes all of these data sets, it does a remap, it does some classifications, and eventually it writes out my solar power plant. So I can either apply this process current as we did it previously, do it on the client. This information product uses all of these services which reside on my server. It's doing the process and writing a dynamic layer out of my client. So here, as I zoom and pan around, here's my information product. Again, this is done dynamically. Now what I really want to do, like I mentioned earlier on, is create a persisted layer, right? And to do that, we have Raster Analytics. So I provide the same set of inputs, the rainfall, land cover, temperature, the elevation data set, but this time instead of picking a raster layer, local raster layer, I transmit this raster function chain to my enterprise, and I tell the system, create a web image layer, create a persisted layer at source resolution. You can specify settings, your output coordinate system. Do you want to process the entire data set or a specific area that you're looking at? The cell size and the resampling method. Specify the output description, temp, test, output, test, solar. You can give it a set of tags, and this is very similar to the sharing experience. You can share with everyone or just within your enterprise, run the process. Now running this process obviously takes a while, so in the interest of time, I've pre-generated the layer. This is the pre-generated layer. As you can see, it's on my portal. It resides on my portal. I've loaded this already into map. This is a persisted layer that is stored and generated and persisted on my portal. Now the same processing, firstly, I can share this processing template. Test, shared, solar. So I've shared the processing template or the processing chain at this point. I can go on ahead and click share. Once I click share, this is now accessible to ArcGIS Online users or to users within my enterprise. We can do the same thing that we did in Pro using the web. Hit analysis, and you guys have seen this previously, the feature analysis tools and the raster analysis tools. Now we've added a little button in here which lets you browse to raster functions that have been shared with you across your organization. Click this, select the template, and the user experience is very similar to ArcGIS Pro. I can pick my data sets and run an analysis. Just save this as temp. Now this takes time again. Again, like I said, it runs within about half an hour as opposed to 6 hours. We're leveraging the power of my enterprise, but clearly we don't have half an hour here. So in the interest of time, here is the pre-processed data set. It's accessible across the enterprise. All of our users on the enterprise can access this data set. So quickly summarizing, we went over processing, client-side processing using desktop, using your local data sets, again using desktop, using image services. Then eventually I went over raster functions and the power of image processing, leveraging the power of server. And lastly, leveraging the enterprise to create persistent data sets. When you use raster analytics, when you're using the power of enterprise, you're creating persistent data sets that are being processed at the source resolution. So now I'll hand it over to Jay, who's going to be talking about the mechanics, the implementation. You can switch. Implementation, deployment strategies, and he'll give you some best practices as well.
Right. Thanks, Vinay. Actually, I want to point out something that you missed in your demo. So it's just that when Vinay is doing the demo in ArcGIS Pro, one thing that he needs to do is actually making sure he's signed to a portal that has the raster analytic capability enabled. Right? All this operation that he did, enterprise-side raster analytic, is actually based on a enterprise ArcGIS that has image server configured on it. So that's the next thing I would like to cover, which is how do you set up the system yourself in your organization or using the cloud platforms. So this is probably the most important slide for this workshop today. So this is typically what a enterprise ArcGIS looks like with the distributed raster analytic enabled. Feel free to take a picture. So basically, you need to install ArcGIS Portal. And the bare bone of a ArcGIS Enterprise consists of a portal and a hosting server. Hosting server is basically a ArcGIS server site with a ArcGIS data store configured to it. And in addition to that, as Vinay mentioned earlier, enterprise raster analysis is not a product, it's a capability of image server. So essentially, you are configuring image servers, and you federate your image server with ArcGIS Portal, and then you assign the raster analysis role to the image server. So you can set up an image server site, which consists of multiple server nodes for the processing, and you federate with your portal, and you configure the raster analysis role to the image server. And in addition to that, so that image server that with the raster analysis role will become the processing engine of your distributed raster analysis. In addition to that, because the image server not only has the capability to run raster analysis, but it also has the capability to share your imagery data, right? So when you are assigning the raster analysis role to an image server, at the same time, image server may also being assigned to host the imageries. So optionally, you can also configure a different image server site that just dedicate to use as image hosting server. So that's another new role that you can assign to additional image server when you configure your enterprise environment. But that is optional, right? If you have a single image server that federates to your enterprise GIS and you assign raster analysis role to it, when you perform distributed raster analysis, all the result imagery will publish as image service on the image server that has the raster analysis role if you don't have the image hosting image server in your enterprise GIS. And also another very important element of this configuration is you have to have a distributed raster data store configured and registered to the raster analysis image server and optionally the image hosting server. I'll get into more details about what distributed raster data store is and why this is important. Again, as Vinay said, for distributed enterprise raster analysis, you can use all the existing data that you already registered to your ArcGIS server, federal ArcGIS server, and use them as input for your raster analysis. So in terms of deployment platforms, if you are trying to deploy this enterprise GIS in your organization with your own hardwares, so what our recommendation is, use your own server machines and make sure that you use a network file share system appliances. There are many different enterprise level network file share storage that are available out there. But the key thing is the storage has to be optimized for frequent small file read and write. And we also support cloud platforms. And the two cloud platforms we support at the moment is, in 10.6, is the Amazon AWS platform and the Azure cloud platforms. And when you are deploying enterprise GIS in these two cloud platforms, we are also utilizing the cloud object storage as raster data storage. And we have ready-to-use cloud formation template for Esri, for AWS, where you can deploy ArcGIS portals automatically. You can also use the command line tool and the Lambda automatic tool to do the deployment on the Amazon AWS platforms. For Azure, we have a Azure Cloud Builder, Enterprise Cloud Builder for Azure. Yes, that's a standalone application that basically another automatic tools, basically a wizard that for you to deploy servers with different roles, including image servers with raster analysis roles. So the next, I'm going to cover the key components of image server that with raster analysis capabilities. Again, as I mentioned earlier, Raster Store is a very important concept to support raster analysis. For those of you who use image server before, you have to know you must know that in order to publish image servers, you used to have to register data store, so that your data is not actually copying to the server storage, but it's being referenced by the image servers, right? So the Raster Store is a new ArcGIS data store type that we created since 10.5. So the idea of Raster Store is this is the place when you are running enterprise raster analysis, distributed raster analysis. This is where the output imagery is going to be stored. So when you're running the distributed service, we're writing out pixels to the Raster Store. And the type of Raster Store that is supported is shared file system. You can create a network file share that tell the service to write imagery to that network file share. Or you can use the cloud object storage, such as when you are deploying in the cloud platform, such as Amazon S3 and Azure Blob Storage. And the way you do that is you first register a cloud store in the ArcGIS Server Manager, and then you create another Raster Store and point it to that cloud store. So that cloud store will be used as the Raster Store. We're talking about imagery output in raster analytic, which will be going into Raster Store. But raster analysis can also be outputting feature data. So for all those feature data that is generated by distributed raster analysis service, they will be stored in the hosting server's ArcGIS relational database. That's why in the previous diagram, you actually need to have a hosting server with the ArcGIS data store installed. Right. So in order to support parallel write of output pixels, we need to create a new raster format in ArcGIS that has that capability, right? So we cannot use a traditional image format such as TIFF or JPEG because it only supports one single file handler. So we created this new file imagery format, what we call the cloud raster format. And this cloud raster format is basically built based on top of our cache data set. So we actually can split the pixel data to multiple files in a folder structure, right? So this cloud raster format will be the default output format for raster analysis tasks. And the pixel data, when you're writing into a cloud raster format, will be split into bundles. And this bundle, the size of this bundle is optimized, and it's not like cache data set where you can configure it. We want to make sure that when you're writing out all those pixels in a parallel, we use the most optimized unit to write out those pixels. This is what it looks like when you're looking at a cloud raster data set written in your file system or cloud storage. All these little bundle files are actually pixel data for your output imagery. And all the CIF imagery that written out by the distributed raster analysis will be published as hosted image service on your image server. Right? The special things about this hosted image service is when you publish traditional dynamic image service, for each image service, you have dedicated server instance, ArcSocs, that is assigned to those imagery services. But for hosted image service, there's actually no dedicated SOCs for this kind of service. So what happened is, when your client is trying to render those hosted image service, the rendering request comes in, and hosted image service endpoint takes that request, and but it actually redirects the request to a service called Raster Rendering Service. And it is Raster Rendering Service which makes the request to the data store and read pixel from it. So that's pretty much everything about cloud raster format. And the next thing is the backend services that when you are assigning raster analysis role to an image server. When you're doing that, and basically what happened behind the scene is, on the image server side, there will be 3 key services enabled. If you go to the server manager and under the system folder, you will see a raster analysis tools GP service being enabled. And there's raster processing image service being enabled, and there's raster rendering service being enabled. So raster analysis tools GP service is basically the entry point for you to submit a raster analysis request. So when raster analysis tools GP service take in a raster analysis request, it just spawned off, and then it spawned off and find all the available raster processing service instance in your server side, and basically use it as a worker to process your output pixels in parallel. And then after you finish processing and it publish as host image service, and all the output rendering requests will be handled by the raster rendering service. And this is what it looks like when you actually go into the raster analysis toolbox. And you see we have a list of building tools that we publish with the raster analysis tools. But you may be wondering why the list is so short when Vinay is showing you this huge diagram of all the supporting features, raster analysis features in 10.6. The key things is this generate raster tool. The generate raster tool is actually a generic tool that takes in a raster function input and the value for the input value for the raster function. So basically, this tool can support all kinds of raster function, building raster function or custom raster function workflow that we have nowadays in ArcGIS. So all this operation you saw Vinay doing, configuring function chains, loading a function template in the web map, and essentially it sends the definition of the raster function to the generate raster tool along with the input information, and it calls the generate raster tool to generate the output for you. We also have other tools that are not implemented using raster functions, such as distance analysis, hydrology analysis, image classification analysis. All those tools are published as separate tools in this toolbox. They cannot be implemented using raster function. Their parallel algorithm is a little bit different. So for those of you who are not using any of these ready-to-use clients, such as Pro or WebMap, the raster analysis service tool naturally comes with a REST API, right? So you can find all the reference about how to use generate raster tools how to configure a JSON raster function object and then submit through the REST API of the raster analysis tools to do the distributed raster analysis. And again, this is just a few links to the REST API reference that I encourage you to explore and find out how you can do that. If you develop your own web application, eventually you will be using the raster analysis services REST API instead of going through those ready-to-use apps. And when we're talking about custom raster function, right, even though we have over 100 different building raster function nowadays, and you can customize them with raster function chains, but we also provide you the capability to extend using the Python API, right? So you can basically write a Python module and use ArcGIS Pro or desktop to create your function chain and test it. And it's essentially, you can basically upload your Python module and the raster function template that point to a Python raster function and deploy this kind of function to Enterprise GIS and allow distributed raster analysis to use a custom Python raster function template. And the way to do that is once a typical Python raster function consists of a py file, a py module, and also a rft.xml raster function template file. So the way you do it is you finish your testing and development using desktop apps and Python APIs, and then you copy them to a specific directory in ArcGIS server. That is the server resources raster functions folder. It doesn't have to be on the system folder, but you can create your own custom folder. But the function, the Python module and function template has to deploy there to allow server to understand how you want to use this analysis capability. Right. So there are just so many different kinds of analysis workflow out there, right? So different kind of analysis operation actually poses different challenges when we are trying to parallelize them using different server machine to actually run them, right? So this is basically a quick review of what kind of different analysis operation there is out there, right? So the distributed raster analysis framework today now supports this 3 different kinds of analysis operation. There's local and focal analysis. What that means is basically you can split your imagery to different small units, and this unit, there's no correlation between these different units, or there's limited correlation. It's just that 1 or 2 padding pixels you need from this analysis. So for this kind of analysis, the parallelization algorithm is relatively simple, right? So you just chop the imagery to small tiles or bundles, and you process each bundle separately by different workers. This is simple, and most of the raster functions behaves this way. So you can simply, the generate raster tool is basically used to support this kind of local and focal analysis. There's also zonal analysis, which expand a little bit. So you need to define a zone where you want to perform your analysis in. A typical example is zonal statistics. So in order to parallelize that kind of analysis, we actually have to do it differently, right? So that zonal statistics is not actually implemented using raster function. It's still relying on the existing spatial analysis GP tools. There's also more complicated, the global analysis workflow, such as hydrology workflow or cost distance analysis workflow, right? All these analysis workflows, we have to treat it differently other than the raster functions. So in 10.5, what we support are the 2 analysis on top, which is local and focal analysis and the zonal analysis workflow. But in 10.6, we added a new global analysis distributed algorithm. So you can also run hydrology analysis and cost distance analysis in parallel. So basically just a quick reference to all these different type of operations, just to make sure you're aware of the difference, the parallel algorithm difference between all this analysis. But this is one of the case study that we are really proud of, the hydrology analysis. The hydrology tool are being parallel in the 10.6 release. Right? So basically what it does is we want to compute hydrological characteristics and flow patterns for the entire United States. And the use of it is to predict like stream flows and if there's any flood coming on. Any of you in the audience that do any hydrology analysis here? Cool. So you'll be very familiar with this workflow. Right? So with the traditional ArcGIS desktop apps, right? Basically, this is, if you want to process the entire United States, this is basically undoable, right? So you have to chop the entire United States digital elevation model into different HUCs, different regions. And you have to process different regions separately. And even that can take days for you, right? So performance immediately suffers when you start to process over 500 million cells with a single machine running ArcGIS ArcMap or ArcGIS Pro. Now with Enterprise GIS, right? Previously, we even for 30-meter United States digital elevation model, there are 25 billion cells and 57 separate processing units. Even for doing that, it takes really long time before. But now, we have done a test to run the entire United States digital elevation model in 10-meter resolution. That's 230 billion pixels. And we can achieve that in a week. That's like 500 times larger data set on a distributed cluster. And last, but I'd like to mention is, if you're not deploying the Enterprise GIS, there's also another option that you can directly utilize the ArcGIS server's raster analysis distributed capability in ArcMap. But since we are kind of promoting people to move away from desktop to ArcGIS Pro, so essentially I would still recommend you to look at the configuration for the Pro client. So basically, we still have this ability for you to call the raster analysis service in ArcGIS ArcMap desktop app. Essentially, when you are running local processing tools with ArcMap, the job is distributed using the local ArcSOCP process, right? That is just utilizing one machine's resources. But essentially, we have a new environment settings that we added into GP environment, which allows to designate a processing server, a processing image server that has raster analysis enabled. And so that your desktop workflows can actually be be shipped off to the server to run there. But the difference here is, it comes with some limitation. The difference here is that because it's actually a local workflow, your input data actually has to be shared with your server account, with your ArcGIS image server account. And the server has to know where to access your input data. And if you're running it in ArcMap, and also the results will not be published as hosted image service if there's no portal in front of your image server, right? And obviously, server account must have write privileged output location. And again, output location may not be registered as a raster store. You can just designate a local file share if the server has permission to write into it. And this workflow also does not support cloud storage. Again, this workflow is kind of going away, but I just want to mention that so that you know there's still option there. So I talk about all these different clients you can use to access the distributed enterprise raster analysis capabilities. So this is basically just a rundown. You can use ArcGIS Pro, the ArcMap desktop app, and you can use the Portal web map to run distributed raster analysis. And in addition to that, you can also use the ArcGIS API for Python to access the distributed raster analysis capability. And for those of you who are interested in that, I will actually be giving a presentation tomorrow talking about how to use ArcGIS API for Python to access the enterprise raster analysis. So I think, yeah, we're on time. Oh, one last thing, which is some tips and tricks when you are deploying the enterprise GIS for raster analysis. And although it is optional, but we still strongly recommend you to split the raster analysis role and the image hosting role. Right? So the image hosting, when you are having a lot of image service published on the same image server that has raster analysis enabled, it's just common sense that you're competing resources, right? So essentially, if you, in your organization, you want to host a lot of image service, it makes sense that to just separate these two roles. Also, when you are processing like super big imageries, there's also a chance that you might need to increase the server maximum heap memory for that kind of workflow. This setting, I don't know if any of you know about the settings in ArcGIS server. Any show of hands? Great. So I can show you later where you can actually change the setting. The default value is 64 meg, but sometimes if you are trying to process like 230 billion pixels, this data set that at this level, you want to increase that memory size. And again, I actually didn't mention it earlier, but when you're looking at the system services that, which is the processing engine for raster analysis, the raster processing service, when you first start up the image server, the default maximum number of instances is always 2, right? So based on the machine that you install ArcGIS server on, you may want to increase that number. So for example, you have like super powerful machine with 12 cores, you can increase that number to utilize the most out of your server machines. Well, again, it's a common sense. And again, another thing that I want to mention here is every time when you submit a raster analysis task, it is utilizing 80% of all the available raster processing instance in server, right? So thinking about a scenario where you have multiple raster requests submitting to your image server with enterprise raster analysis, the first one comes in, will utilize as much resources as possible in order to finish task as quickly as possible. The following ones will use what's remaining, but essentially when the first task release some of the processings that it uses, the second one will come in and try to take as much resources as possible. Yeah, this is just something that I want to mention here because we're working on actually allow user to configure it, right? How much resources you want to use eventually. But it's not there yet, but eventually it will be there. But right now for 10.6 and 10.5.1, this is how the service behavior when thinking about how much resources it's going to use for a single task. Yep. Okay. Now that's everything we want to talk about today, and thank you for listening. And
questions?
Take questions. Yes. Yes, sir.
If you start in raster analytic, creating a raster, at what time is the output data available? Is it when it's finished or when the first pixel bubble has been written?
Yeah, it's a very good question. So the question is, when you start a raster analytic task, at what time the output pixel will be available, right? So, so what happened behind the scene when you submit a raster analysis task is, in the enterprise, in the portal, we'll create a image service first. And then behind the scene, the raster processing service will generate in pixels gradually, right? But I know that you're thinking about tile cache, but it's actually not like tile cache. CIF, although it's built on tile cache, but it can only be available once all the pixels finish generating. Yeah. So you have to kind of wait to let the entire output being written out, and then you can see the pixels through the image service endpoint. Yeah. Yes, sir.
First question is CRF OGC compliant, or is it proprietary?
Good question. So the question is whether CRF is OGC compliant, right? No. Unfortunately, it's our ArcGIS format because it's based on tile cache. Tile cache is also ArcGIS format as well. whether in the future we'll plan to make it OGC compliance, or we'll switch to a format that has OGC compliance, we cannot say now at this point. Yeah, because all this OGC compliance software does not support parallel write at the moment.
Right.
Yeah.
The second question
Yeah.
I have, you presented an on-prem option for data and image server and a cloud
Yeah.
version. Is there not a hybrid version to have image server on-prem and access AWS cloud across the cloud?
Sure. The question is whether there's like a hybrid solution that you can have your on-premise server accessing a cloud storage. Definitely, sure. You can do that, but it's just that you need to consider, right, on-premise environment accessing the cloud storage, right? When you're registering a Raster Store or cloud store in your on-premise server, you can certainly pick a cloud storage and set it as Raster Store. That's not a problem at all. Yeah. Actually, as a matter of fact, we are seeing people who, for example, have their machines in Azure Cloud, and they are using Google Cloud Storage. Yeah, that's doable too. Yeah. Any more questions? Yes, I'll take this one first.
Enterprise deployment pattern, if you've got one server node registered as an image server, the other registered as a raster analytics server, and you have more than one raster analytics node federated with the full.
Yeah, so the question is whether you can have multiple raster stores configured on a single server side, right? Yes, you can certainly do that. Right? You can have multiple raster stores, but I actually didn't mention here the behavior is when you have more than one raster stores, one single raster analysis task will actually randomly pick one. So you cannot say that I have to have this task right into this raster store. That's the current, limitation or implementation for the moment. Yeah. It's just the idea that when you are running out of disk space on one raster store, for example, and it can automatically jump to the other one. Yeah.
If you wanted to scale out, could you add another raster analytics
You can.
server?
Yes. Yeah, definitely. That's actually a server infrastructure, right? It's server architecture thing. It's not specific to raster analysis. You have a server side. You can use auto scalings to increase more machines and like take out machines if you're not using them. Yes. Yes, sir.
Double checking that enterprise pattern when you're creating consistent layers.
Mm-hmm.
Can you choose to overwrite the existing layers? So that if you're using that for downstream, it's always pointing to that same layer that is scheduled to updating. It's always creating a brand new layer.
Yeah. So the question is whether you can override an existing result, right, in raster analysis. At this moment, no. Right? So the way it works is when you're submitting a raster analysis request, it always creates a new image service endpoint for you. Right? When it has to create a new image service, it has to be a brand new one. You cannot give an existing image service and say, please just override it for me. No. And I think it's not recommended to do that. Or you can always delete the result that you don't want earlier. But overriding is basically, it's not like tile cache, right? You do not update the areas that is not going to be updated. You're basically rewriting the whole thing again, right? So overwriting is, you can delete the one that you don't want, but overwriting is not recommended. Yeah. Yes, sir.
So in your architecture diagram, there is a portal. In order to get image service to work, you have to have a portal, right?
No, as I mentioned in another slide, the desktop app, right? Desktop, the ArcMap can also utilizing a standalone image server with raster analysis enabled, right? But there's a lot of manual work you have to do. You have to manually start that service, and you can kind of use it without the portal, but again, it's not recommended.
So that means if you're using on the website, let's say just API,
Yes.
to the image services, you have to have portal.
Not really. You can have a ArcGIS server side. If you're using the REST API of raster analysis tools, that GP tools, it actually does not require you to have a portal.
Hosted by the ArcGIS server.
Yes, that's fine. Yeah. Yeah. It's just for those client apps, for the Pro and for web app, you need a portal in order to run raster analysis. Yeah. Any more questions? Okay. Thank you very much for coming. Any helpful?